Let's look at how ethics have evolved naturally within nature. In a simple instance, mothers protect their offspring. They provide them shelter, X, Y, Z. We can look at these very basic things that are shared across species. Now, we could apply that outside of any bias, because we're talking about evolution, something that applies to all of us here.
Right.
And we could start with that as a normative framework for all the people that are developing AI to push it in a more ethical direction before a bias of ethics can come into place to say, oh, this is more ethical. Well, let's look at the thing that's a basic parameter for all. And that's just taking a strictly scientific format before me bringing in a spiritual one. You follow me on that?
Yeah.
Because this drift can do damage. So can you give a little bit of an example about what this drift does in the algorithms itself?
Well, that's been well shown in, there was one algorithm that was with a large healthcare system in the Northeast.
Sure.
That was predicting sepsis, which is a potentially life-threatening condition, that patients in the hospital who get infection and then the infection becomes widespread throughout the body and they can go into shock and die within 24 hours very quickly.
No, thank you.
And it's very hard to know which patients are going to be vulnerable to that. And if you could even get like 24 hours sort of predictive analytics of who are the patients at risk, then you can watch them, you can put them in the intensive care unit and prevent more people from dying of this disease. So that's been a real good algorithm for old AI, not the generative, just predictive AI. And but in this algorithm, over time, it drifted from being 80% correct to being 50%, which is a coin toss.
Yeah, I might as well just be in there with my quarter.
So, right. Because, and the reason that they think it happened is because over that time, the health system acquired additional new hospitals and groups, and so the baseline population changed.
Correct.
And so that's one explanation for drift. Another explanation for drift is one that we mentioned in the paper, is that the clinical reality changes. So early in COVID, a lot of people lost their sense of smell.
Correct.
Anosmia. That was a signal. And now it's much less common in the current COVID variants.
So you can't train on that to say.
So if you use that old data, then you need to continue to have new data. So so there's all kinds of ways in which, and that's the number one principle, beneficence, which means you have to get it right.
Yeah.
And so that how do we rate or manage models or AI systems in the generative world that we can say this is more likely to be right than that?
Sure. Now, when you talk about the right beneficence, now patients